When we were small, a friend of us used to chant out certain puzzles to us. One of them was double N triple A single R Y. What is the name of the Indian boy? Now we have seven letters. There are two N, three A, one R, and one Y. With many arrangements of these letters, we can get the word Narayan. This is the answer of the puzzle. But the question remains, how many such words can be formed? The words which are distinct, different, and they may or may not have a meaning. But these seven letters will form how many words? This is the question we need to answer in this section called permutation and combination. As we can see, the first place can be filled with seven different letters. So there are seven possibilities there. Mind you, when the first letter is filled, the first position is occupied, then that letter is gone. So you are left with six different letters now, and the second position can be filled with these six different letters. Consequently, the next will be filled by 5 and 4 and 3 and 2 and 1. So in all we have 7 factorial possibilities. So at this point of time, we feel that there are 7 factorial different possible ways in which these 7 letters can be arranged to form a word. But hang on, there are two N's, which means that if the first letter is N and the last letter is N, then in trying out many different possibilities, if we swap these two letters around, we are getting the same arrangement. Now we are looking for different arrangements, not the same arrangement. Hence, we will have to follow this logic. By simply rearrangement of the two n's, we get two factorial possibilities. These two factorial possibilities, although theoretically are different, but they all are giving us the same word. And we are looking for different words. So whatever be the number of words we are getting, those number of words should be divided by 2 factorial. The same logic will apply for A, and we can see that there are 3 A's, which means that they can be arranged in between themselves in 3 factorial, which is equal to 6 different ways. We can see those 6 different ways. Now, there are 7 letters in the word, out of which N is coming twice and A is coming 3 times. As a result, the expected number of words possible should have been 7 factorial. But because there are repetitions, we will have to divide by 2 factorial and 3 factorial. Because n is coming twice, we divide by 2 factorial. And because a is coming 3 times, we divide by 3 factorial. So the actual number of ways these letters can be arranged in distinct possibilities, or the distinct number of words which can be formed, is 7 factorial upon 2 factorial into 3 factorial. Let us now see a formal question. A kind of question that might be there in the textbook or might even come in the examination. The question goes like this. How many different words can be generated with or without meaning using the letters of the word connection? How many of these words end with E and how many of these words start with O? Now let us see the question one by one. The first question is about how many different words can be formed with or without meaning using the letters of the word connection. Now in this word connection, CONNECTION, there are 10 letters. Now out of these 10 letters, O is coming twice and N is coming 3 times. C is coming 2 times. So the repetitions are C is coming twice, N is coming thrice and O is coming twice. Clearly, if there were no repetitions, then the number of words would have been 10 factorial. But now we know there are repetitions, so the distinct number of words are going to be 10 factorial upon 2 factorial into 2 factorial into 3 factorial. The second question is, how many of such words actually end with E? Now should you try to put those 10 possible places where a letter can be filled. In that the last letter has to be E. There are not any more ways about it. There is only a single way about it. So we see that the last letter can be chosen in only one way. The first 9 letters, however, can have any kind of arrangement. Therefore, they can be chosen in 9 factorial ways. So the expected number of ways would have been 1 into 9 factorial. But mind you, there are repetitions here. O is coming twice, C is coming twice, and N is coming thrice. Therefore, the number of distinct words which are ending with E can be given by 1 into 9 factorial, the whole divided by 2 factorial into 2 factorial into 3 factorial. And the last question. The last question is about how many of such words are starting with O. Now the words which are starting with O, there are 2 O's here. So any one of the 2 can be selected. So the first letter can be chosen in 2 different ways. There are 2 possibilities. Remaining 9 letters can be arranged in 9 factorial ways. So the expected answer should have been 2 into 9 factorial. But because there are repetitions, the answer is going to be 2 into 9 factorial divided by 2 factorial into 2 factorial into 3 factorial.